Geometry, Chapter 2, Section 6, Algebraic Proof. Now, an interesting thing about everything you did in Algebra 1, you were basically proving all of those equations you ever solved. I usually call those a proof because it's not rigorous, so it's missing the R in the proof, right? So most of the time, like if you have 2x plus 3 equals 5, you subtract 3 from both sides, you get 2x equals 2, divide both sides by 2, and then you get x equals 1. And you say, yeah, that's my answer. Well, all the things you did, like subtract 3 from both sides or divide both sides by 2, is a step of deductive logic. In the very beginning of solving equations, you had to justify your reason for doing each one of these steps. But after a while, we just kind of dropped the whole justification thing and said, if you know how to do it, then you do it, and then you get to the answer. So what we weren't doing was we weren't stating clearly every time that we solved an equation that we were using the different properties of real numbers. And here I kind of highlighted there for you a list of the properties that you became very familiar with in Algebra 1. All these properties are true, even still in geometry. We can use their names when we're trying to justify any of the steps that we're doing. So what we'll do is work on solving equations or something similar to that. And sorry, there's a fly buzzing around me. And we will justify each step, and it changes what was a non-rigorous form of proof in Algebra 1 into a rigorous form of proof in geometry. And the reason why we practice this is it's something we're familiar with. We start getting used to using all these different properties, and then at the end of it, we'll feel more comfortable when we get into actually doing geometry-based proofs. So we're going to use all of these properties, so you should, in your book, mark this little page as something to reference. So we're going to justify each step when solving an equation. All right. So prove that if negative 5 times x plus 4 equals 70, then x equals negative 18. So just like we were starting to practice with our proofs in the last section, they're going to give you their claim, that's our equation, and they're going to tell you the the conclusion that you should reach, x equals negative 18. So obviously you can see that this problem is not about discovering the value of x. We already know what it is. It's negative 18. We're going to use our steps to justify all of them, and the justifying is the part that I want you to pay attention to. So what would be the first thing you do when you go to solve this problem? Maybe it's distribute, maybe it's divide by negative 5. It's your choice. I'm going to distribute on both of these. So negative 5x minus 20 equals 70. And on the same line that I show the result of what I did, I'm going to write the property that I use, distribution with a B. And it's very common to just abbreviate property as prop. Saves you a little bit of time there. Second step, I am going to add 20 to both sides. And I get negative 5x equals 90. What did I do? I used the addition prop of equality. I forgot the of equality before. You can see we kind of use shorthand when we're doing these because writing the full words out every single time is tedious, and mathematicians are lazy, so we find ways to abbreviate it. I don't want to write of equality for every single time I use these properties. So I wrote of equal sign, and that just means of equality. Next step, we're going to divide both sides by 5. And we're going to get, oh, sorry, I dropped my negative here. That should be -5, so I should divide by -5, which gets me x equals -18. And the justification for that step is the division property of equality. And I've gotten to my answer, which is the conclusion that they said I should reach, and it works. Remember, the justifications are the important part here.